Hi, it's Jacob. Today we're in SAT country with a percentage problem that gives a lot of you guys fits. Specifically, we're talking about practice test number 10, section 4, question 16. It's about two cities, X and Y, and what happens to their populations. I've made a list of the givens, and I encourage you guys to do that whenever you have a lot to keep track of. Now, this is a notation that I kind of use, but use whatever works for you as long as you're consistent with it and it's clear. So in 2015, we know X is equal to Y. From 2010 to 2015, X is up 20% in population, Y is down 10. I went ahead and abbreviated 120,000 as 120 for simplicity. I feel okay doing that because none of my answers are orders of magnitude apart. I can't get the right numbers, but the wrong number of zeros, if that makes sense. And I'm looking for what Y is in 2010. So I have to be able to transfer from X to Y. I have to swing from X to Y. To do that, I need to figure out what X is in 2015. So I love this equation. After is equal to percent times before. The most useful equation on almost any standardized test, including the GRE and GMAT, by the way. So I'm looking for after. I'm looking for 2015. I know I have 120. And again, anytime I'm doing this kind of equation with increases or discounts, I have to manipulate the percentage based off of 100. So this is 1 plus 0.2. And that's a multiplication symbol there in the middle, not a period. So 1 plus 0.2. So it'd be 1, that was really sloppy writing. 1.2 times 120 is going to be the X population in 2015. That's 144,000. So I know that in 2015, Y has to equal 144,000. Now I have to work backwards in time to get what Y was in 2010. I'm going to use the same equation again. I have the after now. I have the 2015. This is for Y. Have the 2015. The percentage of decrease. The percentage of decrease. So I subtract the percent. So it'd be 1 minus 0.1. It'll be 90%. So 0.9 times X. And then I divide these two, of course, to isolate X. Should really extend this to indicate it covers everything. Sorry, I was mumbling to myself. And now I'm going to get Y is equal to 160. And that's it. Relatively straightforward. As long as you're conversant in this formula and this style of thinking, I strongly encourage you to do so. The addition and subtraction of discounts and increases, decays and growth, whatever you want to call it, is incredibly important, particularly on those exponential model questions that the SAT likes so well. Alternatively, on this one, if you kind of pay attention here, you don't really need to do that much. If X goes up by 20% from this number, well, it's going to be bigger, but not that much bigger, right? And Y is going to be a little bit bigger than that. So obviously, since it's got to be bigger than 120, it can't be these two. And this one seems like too much. So if you really had to, although I don't recommend it if you have the option to do it, you could do a pretty good guessing job on this one. Thanks and have a great day.